Yeah, hi. Can you tell me about your recent project?
Okay, recent project. Recently I worked on developing a microservices based application for a retail banking system. Okay, so in this project, I mainly
Mm-hmm.
used Java and Spring Boot. This application's objective was to work on various banking operations like account management, transaction, and customer service. Right. Our team decided to use a microservice architecture to ensure scalability and independent service manageability, something like that. And I was
Mm-hmm.
responsible for designing and developing several microservices, including the processing service and account management service. Okay. So for
Mm-hmm.
inter-service communication, we used REST APIs, and I also implemented Spring Cloud components like Eureka for service discovery and Zool for gateway routing. Right. So the
Mm-hmm.
project was
Okay.
great, and I contributed to the efficiency of the bank's operation and provided a much improved user experience for the bank customers. And I alone didn't work for this project. Actually, I mean, we as a team worked on this project.
Okay. Okay.
Yeah.
So, as you mentioned, Eureka and Zool, can you describe how they increase the efficiency of microservice architecture?
Okay, so Eureka is basically a part of Spring Cloud Netflix. Okay, and it served as our service discovery tool. Okay, so in a microservice architecture like ours, where we had multiple service running, right, it was crucial to have a robust service discovery mechanism. So basically, in that case, Eureka provided us with a central location where all our service cloud register themselves and discover other services as needed. Okay, so this approach simplified the process of locating service instance for communication, and we had an Eureka server where all the microservices would register. I mean, while starting up. So
Okay.
that's was about Eureka, and now talking about Zool. It acted as an API gateway in our architecture, and basically it was kind of front door for all requests coming into our system of microservices. And we use Tool for multiple purposes. Basically, firstly, it provided an entry point for our front end clients, and secondly, we used it for dynamic routing. Where Zool would forward requests to specific microservice based on the request part. Okay, and thirdly, Zool
Okay.
also allowed us to implement a cross-cutting concern like security logging and request filtering at the gateway level, instead of
Mm-hmm.
each working on each microservices. So yeah, that's how I increase the efficiency
Mm-hmm.
by using these things.
Okay. Okay. So, did you use any asynchronous communication pattern or message broker in your project?
Mm, Actually, I'm not sure, but I think we didn't use these patterns in our project. So yeah.
Okay.
Mm.
Okay. Okay. No problem. Moving forward, can you explain how inheritance and compositions are different in Java?
Inheritance and composition. Okay. So basically, inheritance in Java is a concept where one class can inherit the properties and methods of another class, right? So it is a way
Mm-hmm.
to create a new class based on existing class. Okay. Here, let's say new class is a subclass or child class, and the existing class is a parent class. And by using this inheritance, we can reuse our code and increase efficiency. And on the other hand, composition is more like having item means our class can have objects of other class as its member. Okay, so instead of inheriting from them, it includes them, right? And this allows for a more flexible design, and where the compose objects can be easily replaced or changed. So that's how inheritance
Mm-hmm.
and compositions are different in Java.
Okay. Okay. So, can you tell me the purpose of exchanger class in Java?
Okay, exchanger class. Okay, so basically the exchanger class is a part of one Java package, that is java.util.concurrent. Okay, so it provides
Mm-hmm.
a kind of synchronization point where two threads can pair and swap their elements within the pairs, right? and each thread presents some objects on the exchange point and receive the object presented by the other thread. So that kind of exchanger class too. And I can give you an example. So imagine we have
Mm,
two friends who need to
okay.
exchange lunch boxes with each other. They both need to
Mm,
arrive at the meeting point to make the exchange. If one arrives early, they have to wait for the other. This is similar to what what our exchanger class does in Java.
okay. So, in which scenario is it useful?
Scenario. Okay, let me think. Hmm. I think it can be used in data processing. Imagine one
Mm-hmm.
thread is reading and processing data, like filtering out bad data, okay? And another thread is
Okay.
saving this processed data to a database. So I think this way we can use an exchanger to pass the processed data between them. So yeah.
Okay. Okay. Moving to the next question. Can you describe the Java memory model and how does it supported multi-threaded application?
Java memory model. Okay. Okay, so the Java memory model is like a rule book for how different parts of Java program share and use memory when they are running at the same
Mhm.
time. Okay. It makes sure that when one part of the program changes something in the memory, the other parts can know about it and use the latest information. Okay, so this helps in preventing
Mhm.
mixing ups and mistakes when the program is doing many things at once. So that's about Java memory model. Now, talking about how it supports multi-threaded applications. So basically, it makes
Mhm.
sure that when different parts of program or threads are working at the same time, they can safely and correctly share information. Okay, so it's like having
Okay.
rules in a game where everyone knows when their turn is and what moves the other players have made, right? So this prevents the threads from getting mixed up or using outdated information. And I think it is really important for the program to work right and not crash or give wrong results. So yeah, this is
Mhm.
how it support multi-threaded application.
Okay. Now, can you tell me about the Java file recorder?
Java flight recorder. Okay. Actually, I'm not sure about this.
Okay. Okay, no problem. So, do you know what are design pattern?
Yeah, I know. So basically, design patterns are like common solution to a problem in a software design.
Mhm.
Okay, so they are not
Okay.
specific code snippets or algorithm, but they are just concepts or templates for solving a tough problem
Mhm.
or a problem that comes usually in our code, and we can then consider them as a best practice that we can customize and apply in our coding projects.
Mhm.
We have an example like singleton patterns.
Okay. Okay. Nice. So, can you tell me the use case of the singleton pattern?
Okay, use case. Okay. I think a use case for this singleton pattern would be managing a database connection. Okay, so basically by using this, the application maintains just one database connection instance, and which will reduce and resource use, and it will ensure consistency. And the single instance can be accessed globally. That will prevent the overhead of creating multiple connections, and then definitely will enhance the performance and resource
Mhm.
management. So yeah, I think this is the use case.
Okay. Okay. And what about the saga pattern?
Saga pattern. Uh,
Mhm.
Actually, I'm not sure on this.
Okay. Okay. No problem. Now moving to the next question. So, how do you secure Spring Boot application?
Okay, Spring Boot application. Okay, so for securing Spring Boot applications, I mostly use Spring Security, okay, which is a
Mhm.
powerful and a highly customizable framework for authentication and access controller, and it can do a lot of stuff for us related to security. Like we can configure HTTP basic authentication or form-based authentication, and we can then integrate with external authentication providers like auth. So that's about Spring security, and then it's also important to ensure secure communication that we can configure by SSL TLS for our application. And I think apart from these,
Mhm.
I also pay attention to securing endpoints, sanitizing inputs to prevent injection attacks, and managing dependencies is also, I mean, we should consider this to avoid vulnerabilities. So
Mhm.
yeah, that's
Okay.
yeah.
Okay. So, how does Spring Boot simplify dependency injection?
Okay, so basically, Spring Boot simplifies dependency injection by automatically setting up and configuring many parts of our application. Okay, in this,
Mhm.
we don't have to write lots of configuration code. Instead, we just use annotations like AutoWire to tell Spring where to inject dependencies. Okay, Spring Boot figures out the rest, like creating objects and connecting them together. So this makes it much easier to manage and use different parts of our applications without worrying about the setup details. And this dependency injection basically remove the
Mhm.
plate of sorry. So this
Okay.
dependency injection basically removes the extra code. I mean, which are not necessary. Okay, and it can
Mhm.
do a lot of things which I mean, which we should do without Spring Boot. So I think yeah.
Okay. Okay. So, what testing strategy do you recommend for Spring Boot application?
For testing Spring Boot application, basically I recommend starting with unit tests using JUnit to test individual part of our code, right? Then I add integration tests to check how a different part works together. Okay. Then using Spring Test Support, we can load the context, right? Also, I
Mhm.
use mock objects with Mockito to kind of make real components, right? Then finally, I do
Mhm.
end-to-end test for complete application flow. These strategies help ensure our application work correctly at all levels, from small parts to whole system. But one thing I
Mhm.
just want to add. So basically, I don't do uh, I'm not too into these testing things. I do sometimes in my projects
Mhm.
when no testers available. So yeah,
Mhm.
that's all about testing strategy.
Okay. Okay. Now, can you tell me how do you integrate a non-relational database, just like a MongoDB, with a Spring
Mhm.
Boot application?
Okay. Okay. So in order to integrate a non-relational database like MongoDB in a Spring Boot application, first, I think we have to add the MongoDB dependency in our project's build file. Okay. Like POM file. Okay. Then in our application properties, we have to set up the connection details for MongoDB, like database URL, credentials, etc. Right. Then we have to create repository
Mhm.
interfaces in our code using Spring Data MongoDB, which helps in interacting with MongoDB, right? Finally, we use these
Mhm.
repositories in our service to save, retrieve, and manage data in our Mongo database. So that's how we can integrate a non-relational database with a Spring Boot application. So I think I think it's a
Mhm.
similar than that what we do for a relational database.
Mhm. Okay, so moving to the next question, how would you implement catching in a Spring Boot application?
So basically, in order to implement caching, first we have to add a caching dependencies like cache or caffeine into our project, right?
Mhm.
Then we should enable caching in our Spring Boot application with some annotations like enable caching, right? Then we have to use cacheable annotation on the methods to store the results in cache, right? And then there is an annotation called cache evict to remove the outdated data, right? So by using
Mhm.
these annotations and setup, this helps our application run faster by reducing unnecessary data fetching, and then we are able to implement caching. Yeah.
Okay. Okay. So, can you describe a scenario where we can implement a synchronous messaging in a Spring Boot application?
Okay, so basically in a Spring Boot application, asynchronous messaging can be used where tasks can be done separately from the main workflow. Okay, for example, let's say in an online store, when a customer places an order, we can send the order details to a queue using asynchronous messaging, right? I think this way the order processing, like checking inventory or arranging delivery, happens in the background, allowing the customer to continue browsing or doing other thing without waiting. So I think that would be one of the scenario.
Okay. Okay, nice. So, let's say you notice that a Spring Boot application you are working on is significantly slower in production than in development environment. How would you go about fixing the problem?
Okay. Mm, okay. Let me think. Mm, Okay, so when a Spring Boot application is slower in production than in development, so I think first I would start by checking the logs for errors or slow processes, like why it is slow, and okay, so then I would use monitoring tools to track the performance metrics, like what is memory usage, what is CPU load, and what are the responses time, etc., etc., right? Then I would compare configurations between development and production to find the differences. Maybe we are missing something in the production, okay, that is already there in the development, okay. Then I'll check if the database queries are optimized, and if external services used in the production are affecting performance. Maybe let's say we are using some external services, let's say we are dependent on some external endpoints, okay. Those endpoints are working
Mm-hmm.
in dev, I mean their dev environment are working fine, but theirs prod environment are not working as
Mm-hmm.
expected. So I would also check those, and then after finding these things, I will make the decision and improve the application on the basis of root cause what I got
Mm-hmm.
by analyzing these.
Okay. Okay. Now, suppose you need to migrate an existing application to use a new
Mhm.
database schema in Spring Boot without downtime. How would you plan and execute this migration?
Actually, can you repeat the question? I think I missed it.
Okay. So, suppose you need to
Mhm.
migrate an existing application to use a new database schema
Mhm.
in Spring Boot without downtime.
Mhm.
So, how would you plan and execute this migration?
Mm, okay. Mm, let me think. So
Mhm.
I think in order to migrate an application to a new database schema in Spring Boot without downtime, first I would create a new schema that works with the old and newer versions, right? Then I would update the application to support both schemas, right? Gradually, I mean, I
Mhm.
would gradually shift from old to new. Okay. Then I would use database migration tools like Flyway or Liquibase in order to control the changes. Okay. Then I would test thoroughly in a staging environment. Okay. Then finally, I would deploy the update with the new schema in production, and I'll ensure continuous operation throughout the process. So I think this is how I would plan executing this migration.
So, as you said, you use Spring Cloud in your project. What is the Spring Cloud and how it is useful for building microservice?
Okay, so basically, Spring Cloud is one of the components of Spring Framework. Okay, it basically helps managing microservices. Imagine we are running an online store application like, for example, a virtual mall. Okay, where different sections handle different tasks. Okay, so in this application, basically each store or section is a microservice. Okay, so one section handles customer logins, another manages the shopping cart, one take care of processing payment. Okay, and the other list and the other list all the products. Okay, so these are the components of the online store application, and we can further divide these components into the microservices. Okay, now we by using these microservices, we don't need to worry about. I mean, we don't need to focus on whole application. Instead, we can work on at individual component. So,
Mhm.
and due to which we can reduce the errors in our application. Okay, when building and managing such an application can be complex because we need all these sections to work together seamlessly. Okay, so a customer should be able to log in, add items to their cart, pay for them, and browse products without any problems, right? So we have to worry about these things while designing a microservice architecture or application, and that's where Spring Cloud comes into the picture. So that helps building and managing such a big and complex microservice application, and it helps. And also it helps microservices in connecting the section, balancing the crowd, keeping secrets safe, etc., etc.
Okay, okay. Is it possible to change the default server?
Yes, we can change the default server.
Okay. How can we change it?
Okay, so I mean, Tomcat is a default server, right? Uh, in our Spring Boot application. So we first we have to exclude that dependency in the POM file and include the server which we want to add into our application. Okay, so we can, let's say there is a server Jetty, so we can then include the Jetty server dependencies in the POM file, and that's how we can exclude the default server and include our um, own server. I mean our server.
Okay. Can you tell me how OOPS is helpful in Spring Boot projects?
Mm, okay. So basically, by using OOPS, we can organize our code. Okay, we can reuse our code. Okay, so these are some things we can do through the object-oriented concept in our project, and definitely it will enhance the security. Like now, we can use the private variables, classes, etc. Right, and uh, yeah, so that's how OOPS helps in our project to reduce, I mean, increase the efficiencies.